Assalamualaikum warahmatullahi wabarakatuh. My name is Ziyad bin Zahari and my group mates are Ahmad Fadlin Akmal bin Kamaruddin, Adi Hazim bin Luqman, Ahmad Naqiuddin bin Saifuddin, and Zulhilmi bin Abdul Aziz. So, in this assignment, we are given a question to choose one engineering case study that requires solving ordinary differential equation. So, we need to identify two ODE methods that can be used in solving the problem. So, this is the case study that we have chosen for the assignment. So, the problem statement is the ordinary differential equation must be solved with two of the ordinary differential equation method using computational tools, which is MATLAB Octave. So this is the equation of the elastic curve, where L is 6.5, W0 is 8.75, E equals to 210 GPa, and L equals to 113 multiplied by 10 to the power of 6, and V0 is 0, and step size is 0.25. So in this assignment, we choose two methods to use, which is the Euler's and Hertz method. So this is the Euler's method, and this is the variable used, the step size, and the loop for Euler's iteration. And this is for the coding for the graph of analytical solution, and this is the graph for the Euler's graph labeling. So as you can see, when we use the Euler's method, this is the graph of deflection V against displacement X. And we move on to the Hertz method. This is the coding for the Hertz method. The values of the equation, the initial condition, the call of the function or equation, and the loop for the Hertz method. And this is the coding for the analytical graph, Hertz graph, and labeling. So we try to run this. So this is the graph for the Hertz method. As you can see, the graph of deflection versus displacement. So by looking at the graph of Euler's method, we can see that it mirrored its analytical solution. It also shown that deflection V is inversely proportional to the displacement, which is when displacement increases, deflection decreases. Since this is the first order method, the local error is directly proportional to the square of the step size that make the accuracy can be increased by reducing the step size. So for the Hertz method, we can see from the graph that it shows beam deflection V is inversely proportional to the displacement, which is when displacement increases, deflection decreases. It does not mirror the analytical solution since it is approaching the analytical line. The accuracy of this graph can be improved by quadratically. So the discussion is based on the graph obtained. We can see that there is not much difference between the two methods. However, as the accuracy of the Euler method only increases linearly as the step size decreases, and the accuracy of the Hertz method increases quadratically, we would conclude that Hume's method is relatively more accurate than Euler's. This is because the truncation error is only differentiated by the power of the step size, where step size for Hume's method is 1 degree higher than Euler's method. Okay, that's all from me. Thank you for watching.